12 astronauts have landed on the surface of the moon. They had only 3 days in zero gravity prior to their landing. A trip to Mars will require at least 3 months, and possibly as many as 6, of traveling in zero gravity. How will the astronauts react to this period of time? My name is Ben Pearson, the Roadster Tracker, and today we're going to take a look at how well the human body can survive a trip in zero gravity. Simply exiting the lunar lander was a bit of a challenge. Walking on the surface of the moon with a bulky spacesuit proved even more challenging. The pressurized suit was difficult to bend and led to a number of mishaps during the lunar excursions. Among other complications were their time in zero gravity itself. Astronauts returning to Earth even after just a few weeks have been known to faint. What changes happen to the human body that will make a trip to Mars so difficult? There are 3 primary areas that I'd like to focus on today, namely balance sensing, bone loss, and muscle loss. The ear senses balance by sensing a fluid flowing through the ears. This mechanism does not work well in zero gravity at all. In fact, the body's ability to even sense its orientation is greatly reduced. This probably contributed somewhat to some of the difficulties in the Apollo astronauts and would certainly contribute to a mission to Mars. In this video, ESA astronaut Tim Peake is testing the limits of balance on the International Space Station by spinning himself in circles. Note that there are only a few moments that he is actually dizzy while doing this experiment, namely at the end of the test, when he is suddenly stopped. Most of the time, he is quite fine and is not experiencing any sensation of dizziness at all. This is because the human body's ability to measure its orientation is reduced in zero gravity, and thus when one experiences gravity again, it will have some difficulty. The next source of degradation is bone loss. The average rate of bone loss for an astronaut in space is about 1% per month, where even a typical osteoporosis case will lose the bones at a rate of 1 to 2% per year. Thus, it is higher than even some of the more extreme cases on Earth. Most of this bone loss occurs in the lower parts of their body, which are essential for moving around on the Earth, in part because of the tendency of the blood of the body to remain in the head, and in part because the legs are used so heavily on Earth and are hardly used at all in space. While it has not been noticed that astronauts have an increased tendency to break bones when they return to Earth, this is something that is still cautious, and as there has not been many astronauts to observe, it is still a possibility that this could be an increased risk for a mission to Mars. There have been some things that have been tested to improve this, but nothing yet has been proven effective at reducing the bone loss in astronauts in space. Finally, there is muscle loss. Muscles are less used while in space. When one is simply walking from one part of a building to another, one is doing some form of exercise, but this is not done on orbit at all. Astronauts who spend an extended period of time in space must exercise for 2 hours in order to prevent damage. This has been shown to be effective at reducing muscle loss, and perhaps will reduce the bone loss previously discussed. When astronauts first arrive on the surface of Mars, they will have been in zero gravity for between 3 and 6 months. Most of the astronauts who return to Earth after this length of time are barely able to move when they first land, requiring special treatment for the first few days to adjust their bodies to gravity. No one knows if Mars's gravity, which is only about a third of Earth's, will cause the same degree of challenge as returning to the surface of Earth. They will then spend approximately a year and a half on the surface of Mars, and then spend another 3 to 6 months in zero gravity returning to Earth. No one has undergone reduced gravity for such an extended period of time. Astronaut Scott Kelly is the American who has the longest time spent in space. He recently undertook a year-long stay on the International Space Station. This video shows what happens when he returned home. Note the large number of people he had to assist him and the difficulty he had in leaving the spacecraft. The first Mars astronauts will just have each other. No one knows exactly how they will fare in Mars's reduced gravity after such a long stay in zero gravity, and there is no good way to test this. Likely they will remain on the spacecraft for several days adjusting to the Mars gravity before they go outside of the spacecraft at all. They also might experience some of the falls that the Apollo astronauts did, particularly when walking on the surface with the bulky spacesuits. However, the Apollo astronauts, if there was some difficulty, could always return to Earth within just a couple of days. This will not be a possibility for the astronauts on Mars. One method to counteract this for the time spent in deep space would be some form of artificial gravity. This kind of gravity is created on Earth by centrifuges, such as the one you see here at Goddard Space Center. These could also potentially be placed inside of a spacecraft, although you will note that the size of this is very high, and it was much too large to fit into a spacecraft. Centrifuges must be large in order to keep the feeling of artificial gravity roughly equal between the head and toes. Otherwise, it will cause their own sets of issues. Let me know whatever questions or comments you guys have about this or any other space exploration topic. Thank you for joining me, and until next time, keep on tracking. Take care.